Okay, in this next lesson we're going to be talking about some difference formulas, and we have them listed for cosines, for sines, and for tangents. So the first thing you want to do is pause this video and copy down these formulas, and then after that we're going to work some problems using these formulas. Okay, before we get started in using our formulas, let's just warm up on these two evaluation problems right here. So what is the sine of pi thirds? So we go to pi thirds, and sine is your y value. That's going to be square root of 3 over 2. And if we multiply that by the cosine at pi 6, so we go to cosine pi 6, that's also going to be the square root of 3 over 2. That's just going to simplify. A square root times a square root is just the 3, because this would be 3 times 3 is 9, so the square root of 9 is 3 over 4. Okay, also let's calculate the tangent at pi fourths. Tangent is your sine over your cosine, so that's just going to be 1. Tangent at pi 6, sine at pi 6, excuse me, let's go to pi 6. The sine value is just going to be 1/2. So we calculate that 1 plus a half is just going to be 3/2. So just a little warm up on some evaluation there. Okay, so the first example is use the sum or difference formulas to find the exact value of the trigonometric function. So sine of 13 pi 12ths. Well, this clearly is not on the unit circle, but to use sum or difference we need to have an alpha and a beta. So I wrote these down over here just to recall. And we want to rewrite as a sum of two angles, alpha and beta, whose values are known, such as the known values that we have most often, which some of them are like that we have on our unit circle: pi 6, pi fourths, pi thirds, or pi halves. These are very familiar to us and on our unit circle. So if we're able to get to any of these, we're in business. So first of all, let me come over here as an example and say, all right, I have 13 pi over 12. I need to break that into two separate fractions. So let's just say over 12 and something over 12 so that I can add them together. What could give me one of these, for example? One thing that I could do, let's just say, is 9 plus 4 is 13. So let's say I would have a 9 pi plus 4 pi would give me 13 pi. And then what does this reduce to? This particular one is going to reduce to a pi over 3, which is nice because it's one of my very common ones. Okay, so then let me just simplify this side, which is just 3 pi over 4. So I'm going to let this be alpha, and I'm going to let this be beta. This is one example that will work for this particular problem. Okay, so you'll get better at that as you go. Let me come back over here to our original problem and rewrite this as sine of alpha, 3 pi over 4, plus beta, which is pi over 3. So I'm just going to put myself a note, alpha, beta, right there. That means I'm going to be using this formula. So it's going to be sine alpha plus beta is equal to sine of alpha cosine beta plus cosine alpha sine of beta. And then I'm going to substitute those values in. Okay, so I put 3 pi fourths in for alpha and pi thirds in for beta in this equation, in this formula. Now let's evaluate sine of 3 pi fourths. So we come here to 3 pi fourths. The sine is just going to be square root of 2 over 2. Cosine of pi over 3. Cosine is the x value. That's going to be 1/2. Now we're at cosine of 3 pi over 4. Negative square root of 2 over 2. Go to sine of pi over 3. Sine of pi over 3 is the square root of 3 over 2. And now algebraically, we just want to simplify this. which would give us square root of 2 over 4 plus, or actually it'll be a positive times a negative is a negative, so it'll be negative square root of 6 over 4. Now, if we wanted to at this point, we could factor out a GCF of a 1/4, and oftentimes I think my math lab will do that. So if I take out a 1/4, that would leave me with the square root of 2 minus the square root of 6. And this would be our solution. Okay, same direction. Use sum or difference formulas to find exact values. We have cosine, so I pulled the cosine formulas over there. We want to try to rewrite this in terms of an alpha and a beta. So I'm just going to go off to the side and do some scratch work. So I'm going to say 7/12, 7 pi 12, excuse me. And I'm going to put them both over 12 and pick, let's do 4 plus 3. 4 pi plus 3 pi, because when they simplify, that's just going to be pi over 3, which is on the unit circle, and so is pi over 4. So I'm going to let this be alpha and this be beta. So rewrite it and write your formula over here like we did on the last problem. Okay, so I rewrote this as cosine alpha plus beta, and pull my formula that matches this. And then I plug in pi over 3 for alpha and pi over 4 for beta, and this is what I'm looking at. And now we want to pull our unit circle and evaluate these. Alright, cosine of pi over 3. So go to pi over 3, cosine of pi over 3 is just going to be 1/2. Cosine of pi over 4 is going to be the square root of 2 over 2. Sine of pi over 3 is going to be square root of 3 over 2. And sine of pi over 4 is going to be square root of 2 over 2. Okay, now let's multiply this. That's just going to give us the square root of 2 over 4 minus the square root of 6 over 4. Once again, we can factor out a GCF of 1/4. So if I pull a 1/4 out of the first one, I'll be left with square root of 2 minus the square root of 6. Okay, our next example, so what if we ask you in degrees instead of radians this time? Sine of 15, but we want to rewrite using evaluate using sum or difference formulas. So I can either add angles together or subtract them. Well, let's look at the main ones right here in the first quadrant, 30, 45, and 60. Which combinations of these could get us a 15 degrees? So if I rewrote 15 degrees, it's clear to see that we could do a 45 minus a 30 degree and let this be alpha and this be beta. So let's go ahead and rewrite this, labeling our alpha and our beta, pulling our formula over, and evaluating. Okay, so we're going to have the difference formula over here, so we jot that down and then we plug in 45 for alpha and 30 degrees for beta. Let's go to our unit circle and evaluate. Sine at 45 degrees, it's going to be the square root of 2 over 2. Cosine of 30 degrees, cosine is square root of 3 over 2. Cosine at 45 degrees is going to be square root of 2 over 2. And sine at 30 degrees is going to be 1/2. Now algebraically we want to simplify this. Square root of 6 over 4 minus the square root of 2 over 4. Just like we've done consistently, we can pull a GCF of 1/4 out and we would have square root of 6 minus the square root of 2.